Hello everyone. I want to present a paper for Biospin Journal Club. And this paper is published in Physical Review Applied in the year of 2019. And the title is Experimental Demonstration of Spintronic Broadband Microwave Detectors and Their Capability for Powering Nano Devices. For this paper, there are many contributors from the countries of China, Italy, USA, and Greece, and so on. Before mentioning the finding of this paper, I want to give you a simple introduction about energy harvesting and their concept. So let's start with it. We have several harvestable energy sources for the ambient media. So these energy sources can be categorized like thermal energy, radiant energy, and mechanical energy. For the thermal energy, we can list body heat, or machines like this. For the radiant energy with emissions. For the mechanical energy, we can list body motion, airflow, vibrations, and so on. This paper is focused on harvesting energy from the RF emissions. So what are the RF energy sources? As you know, we have mobile phones and we have radio and television broadcast stations. We have mobile base stations and Wi-Fi routers. Basically, we can say a wireless communication system can provide this RF energy for the ambient media. In order to harvest this energy, there are many different types of devices, and it has a long story, lies back to the invention of Schottky diodes. As the time passed, several types of devices based on Schottky diodes has been invented and tested for RF energy harvesting. As the time passed, the efficiency of these devices are increasing and reaches to a limit. This limit is known as thermal voltage limitation in Schottky diodes. After 1960s, several types of diodes has been invented, and namely they are Esaki tunnel diodes, metal insulator metal diodes, and spin diodes. This paper is based on the spin diodes, and they can be fabricated by magnetic tunnel junctions. As here you can see all of these studies, as the time passed, they have an increasing trend in the efficiency. So the main motivation of these studies are to increase the efficiency of these devices. So let's talk about magnetic tunnel junctions and its structure. Magnetic tunnel junctions consisting a free layer and an insulator layer and a reference layer. And in this study of the paper I want to talk about, they used for the reference layer as platinum manganese for antiferromagnetic, and coffee and antiferromagnetic was 15 nanometer, and coffee layer is 2.3 nanometer, and ruthenium layer 0.85 nanometer, and coffee B for 2.4 nanometers. These layers creating the reference layer of this device. For the insulator barrier, they used MgO in the thickness of 0.8 nanometer. And for the free layer, they used coffee B material in the thickness of 1.65 nanometer. And this free layer has another property. It has a tilted magnetic anisotropy, which affects the efficiency of these devices. And here they used tilt angle 55 degree. In order to characterize this device, they made a design of experiment. And this experimental circuit consists of a signal generator. And this signal generator can create RF signals with different powers. And it is connected to a bias T, and the other side is connected to a device. This bias T can separate DC voltages created at these terminals and can give us a DC voltage separately from the AC signals. And we can observe these DC voltages by using a voltmeter here. So based on this circuit, they made several experiments. So let's talk about it. For the first experiment, they swapped frequency at a constant power, which is very low, 0.1 microwatts. And they measured the voltage created at these terminals. When they swapped the frequency at this power, they observed a resonance-like behavior at 1.1 gigahertz. And they simulate this behavior, and they observed the magnetization is circulating around y-axis. So for the next step, they did the same experiment by increasing the RF power. At this time, they observed a rectification voltage is almost constant for broadband region. And they observed a very different type of behavior of the device by simulating this behavior with this power. They observed magnetization is switching from one axis to another, but it is not circulating at all. Let's say if it starts from here and goes like this and comes back to its initial position. It means that it has a reversal behavior. Also, we can talk about this broadband region. Many devices casting RF signals at this region. So it is very important to observe a rectification voltage at this band. So this device has a property to rectify the signals at this region. It is very important to mention here, there was no external magnetic field applied to the device for these experiments. There was no magnetic field, only the RF signals generated from this signal generator. In addition, there was videos in the supplementary materials. They simulated the RF, they simulated the ellipsoids, elliptical nano devices. This is the elliptical nano device. This is the free layer of the device, and they simulated for the 0.1 microwatt RF power. So I don't know if video is okay or okay. You can see in the video magnetization or magnetic moments is circulating around its axis without any switching behavior. It's only circulating for the low power. When we increase the power, the magnetization can switch, but not circulating at all. It goes back to its initial position with a reversal behavior. These two findings are very interesting and very important result of this device. For the next step, they wanted to know what will happen if we apply a magnetic field to this device. Can we tune the absorption mechanism by applying different magnitude of magnetic field? So they did an experiment for it by using the power of 3.2 microwatts, and they swapped frequency under different magnitude of constant magnetic fields, and they record the rectified voltages. When they do this, let's start from here, minus 75 Ørsted. They observed this black line. It was very low compared to other signals. And when they decreased magnetic field up to 0 Ørsted, they observed an increasing trend in the signal. And when they changed the polarity of magnetic field, they observed more voltage, in the magnitude, they observe more voltage. And if we cut this signal from this at 250 megahertz, and we can draw a graph for this rectified voltages. And if we display the magnitude of this rectified voltage, it gives an increasing trend by the applied magnetic field for the positive sides. So this is another interesting result for this device. So we can tune the rectified voltage by applying magnetic fields. Another experiment is they swap the power between the power interval of 0 microwatt to 20 microwatts. When they apply up to 5 microwatts, they observed in the rectification voltage as an increasing trend. After this power, 5 microwatts, they observed a saturation behavior. This is another interesting result, and this device can be used to recognize the RF signals. I just forgot to mention about this. They swap power at different constant frequencies. This was 250 megahertz, and another is 500 megahertz. And simulation data gives similar results. This device is very sensitive to low powers, and the responses almost give a saturation for higher powers. So it is very useful to harvest energies. For the next experiment, they changed the experimental setup. Instead of an RF signal generator, they put an antenna that can receive the RF sources from other devices. And there was a distance between RF source and antenna. It is namely called D here. And the DC voltage generated at this device, nano device, is connected to another black phosphorus nano device. And there is an ampere meter here that measures the current passing through this device. And this device has a property of it's when it is exposed to light, it can behaves like more conductor, and when the light is off, it behaves like more insulator. So we can test the current passing through this device by applying light on off. It is a very interesting experiment. Based on this circuit, they made several experiments. First, they put a radio source, which is done by a signal generator at constant frequency. This is the 500 megahertz, and they swap power, and they observe the voltage rectified voltage is increased by increasing the power, and they observe the current passing through the device. And they observe this voltage, and relation between voltage and the current is quite linear. As the voltage increased, also the passing current is also increased. For the next experiment, they used different devices instead of RF generator. They used a walkie-talkie and radiophone, and they are placed differently. Walkie-talkie is placed 5 meters far, and radiophone is placed at 1 meter distance. So when they measure the signal by time, and they just on off this device, and they observe the voltage created in the nano device. And they repeat experiments several times, and they observe the same results. For the walkie-talkie, they observed almost 150 microvolts. And for the radiophone, they observed almost 100 microvolts. So for the next step, they wanted to know what will happen if we put different type of sources to, if we apply different type of RF signals to this harvesting device. For the first device, they put a signal generator, and for the second signals, they put a signal generator and radiophone together. So it is simultaneously applied RF signals. So as you can see here from the time-dependent experiment, there was no signal, and this device provides 0 voltage. And when the RF signal generator on, they provide a constant voltage, almost 100 microvolts. In addition to this device, when the radiophone is on, the signal is added to this signal. Like here, it was almost 100 microvolts. So it is shifted almost 1 microvolts here. Here you can see almost 1 microvolt, it is increased. It means that we can harvest energy from different sources simultaneously, and it behaves like additive, not destructive or independent. So this is another interesting and remarkable result from this device. For the last, they did an on-off experiment by using light. When they put light on the black phosphorus diode transistor, when the light was on, the current passing through this device was high. When they turn off the light, the current passing through this device was low, but not 0. So when they repeat the experiment, they observe the same thing, almost very constant behavior. So this is another proof for this device. I mean, power generator can be used to power up the devices. So it was very quite enough to power up devices. For the conclusion, it has been experimentally demonstrated that the spintronic diodes based on MTGs with a canted-free layers can act as a nanoscale electromagnetic energy harvesters, opening a new direction for research in nanoscale spintronic energy harvesters. Another conclusion is experimental results also demonstrate that the power generated by the nanoscale spintronic diode is sufficient to derive active currents, derive active devices for applications in biomedical, wireless sensing, and portable electronics. You can find more informations in the paper, also in the supplementary documents. Thanks for watching.